Okay, I will repeat first. So the question is to find the volume of solid of revolution obtained by revolving the plane region R, bounded by, okay, y equals to square root of x, the x-axis, the line x equals to 4 about the x-axis. Okay, so that's the idea. Now, we sketch the region first, and then consider a thin piece of the region, and assume that its width is delta x, and then the distance from 0 to this thin piece is x. And of course, since the formula is y equals to square root of x, so the length of the this piece is square root of x. Okay, so if we want to revolve, okay, if I will throw y equals to square root of x there, and then suppose that we revolve this through the x-axis, okay, then we will have this part, and then the corresponding slice or piece of slicing is, let's say, this one, okay, and this the shape will be looks like a cylinder, okay, so the cylinder, and then we know that the cylinder, the thickness of the cylinder is delta x in this case, and then of course the volume of the cylinder is just the thickness multiplied by the area of the base, and the area of the base is a circle of radius square root of x. So if we consider the volume, approximate volume of the thin piece here is just the thickness is delta x, so delta x multiplied by the area here, multiplied by the area of the base, and the area of the base will be pi, and then the radius is square root of x, so pi square root of x square delta x. So in this case, you will have pi x delta x. Okay. Of course, if you take the summation, okay, the volume, the total volume is approximately the summation of pi x delta x. And if you take the limit as delta x tends to 0, you will obtain the volume V as the integral of pi x dx. Of course, x varies from 0 until x equals to 4. There. Okay, so in this case, if you simplify, you have pi multiplied by x squared over 2, 0 until 2, sorry, 0 until, which one? So until 4. So you have pi 4 squared over 2 minus 0. That will be 8 pi. The volume will be 8 pi. Okay, so this is the example for method of this. Okay. Similarly, you may also revolve the region about the y-axis as well. Okay. For example, okay, so this is the example 2. If you want to revolve the region, but now about the y-axis, then okay, so let us consider the following example. Now you will have okay, so now find the volume of the solid generated by revolving the region bounded by the curve y equals to x cubed, let's say, and then the y-axis and the line y equals to 3 about the y-axis. The y-axis. Okay, so in this case, so first, let us sketch the region. So x and y, we have this is the curve y equals to x cubed, and then suppose that we have the line y equals to 2 here. Okay, so the region would be this one. Yeah, this is the region, and the same as before, the idea is that to consider a slice of the region, say this case in this one, the thickness here. Now let us consider that the thickness here is delta y, and this is a y as well. Of course, if this is y, then you have to know that the line of this line segment will be, okay, the inverse of x cubed. So x will be equals to y to the power 1 over 3. Okay, so the distance here, if this is y, then we have the length segment of the big one here is y to the power 1 over 3. Okay. Okay, so now we have to revolve this about the y-axis like this. So if you consider the picture, then you'll have, okay, so have this, I have exactly identical curve y equals to x cubed, but now you have to revolve this about the y-axis. So you have this one. Okay, so the corresponding piece of region will, let's say, will correspond to this one. Oops. Okay, so let us suppose that you have, okay, so here once again we have a cylinder, and its thickness is delta y, and then if we want to approximate the volume, then we have to calculate the area of the cross section here. So if this is y, then we know that the radius, okay, the radius is this one. Radius is y. The length of this radius is y equals to x to the power 1 over 3. Okay, so we want to calculate the approximate value of the volume delta v. This becomes pi y squared. So pi x to the power 1 over 3. Oh, sorry, make a mistake here. Y equals to x to the power 1 over 3. So x equals to, okay, so here is x equals to y to the power 1 over 3. So we'll have the radius is y to the power 1 over 3 squared multiplied by delta y. So in the end, we have pi y to the power 2 over 3 dy delta y. Of course, we have to take summation of v here. So v is approximately the summation of pi y to the power 2 over 3 delta y. And if we take the limit as delta y tends to 0, then we have y equals to integral pi y to the power 2 over 3 dy. Of course, what is the range of y here? Y is in between 0, sorry, The line is, oh, the line is y equals to 3. So should be 3 here. So the integral would be from 0 until 3. Okay. So once again, if we want to calculate the volume V is pi integral from 0 until 3 y to the power 2 over 3 dy. That will be pi. Okay, we have to take a look at the antiderivative of y to the power 2 over 3. So that will be 1 over 2 over 3 plus 1 y to the power 2 over 3 plus 1. And put 0 and 3 there. So in this case, we have pi multiplied by 2 over 3 plus 1 is 5 over 3. So 3 over 5 y to the power 5 over 3. Yeah. Okay, any question or comment so far? Of course, you have to calculate this. Pi 3 over 5 multiplied by y to the power 5 of 3. So that will be 3 to the power 5 of 3 minus 0. That will be 3 to the power 8 over 3 over 5 pi. That's the volume. Okay, any question or comment so far? Any question or comment? Up to this point, any question?
No, sir.
Okay. Okay, so that's the method of this. Yeah. If you want to take a note or review. Okay, so let us continue. Yeah, so that's the application of the example of the method of this. Now let us consider a modification of this one. Okay? We call this method of washers. Method of washers. Washers. Okay. And in this case, the idea is that the region is usually bounded by two curves. Okay. And let us consider the following example. Okay. Okay, the example will be to find the volume. Find the volume of the solid generated by revolving the region bounded by the parabola y equals to x squared and y squared equals to 8x about the x-axis. Okay, so now let us take a look at the sketch or the region, sketch of this region.
Sir, you're muted. Sir, you're still muted, sir.
Sorry, I unmute here. Okay, so if you revolve the region about the x-axis, then you'll obtain small. Okay, so I will draw separately. You will have a small. You'll have a thin cylinder here, but okay, so you only have this one. Okay, and the thickness is delta x, and then you should multiply it by the area of the base. So the area of the base is exactly, okay, the area of the base is exactly, you will have a two circle. Okay, the first circle is this one. The second circle, let us consider this one. And the radius of the first the small circle is, okay, so this is the equation is y squared equals to 8x. So in this case, we should write it as y equals to square root of 8x. So the radius of the small circle is square root of 8x. And the radius of the bigger circle here is y equals to x squared. So you have, oh, sorry, the other way around, right? Sorry, I make a mistake. Okay. This is should be as follows. So the smaller one is, this is the graph of y equals to x squared. So the smaller one will be x squared there, and the bigger one, okay, is square root of 8x. Okay. And x is from 0 until 2. So if we want to obtain the estimate of the volume, okay, then delta V is approximately is the volume of a cylinder, and its base is this region. Okay, it's this region only. So the area of the base will be pi square root of 8x squared minus pi x squared. Okay, so just pi, the larger radius square minus pi smaller radius square, and then multiplied by the thickness. The thickness is delta x. So in the end, you will have delta V equals to pi, you can simplify it, 8x minus x to the power 4. Yeah. Delta x. Okay, from this construction, any question or comment? Okay, so I will go back to the whiteboard to write the solution. Okay, of course, sketching the graph is a part of the solution. Okay, so first I will have delta V is approximately pi square root of 8x squared minus pi x squared delta x. Okay, and in this case, you will have this one equals to pi 8x minus x to the power 4 delta x. And in the end, if you take the summation, then you will have the summation of pi 8x minus x to the power 4 delta x. And if you take the limit as delta x tends to 0, you will have v equals to integral from 0 until, okay, so you have to be careful. You have to look for the intersection between the curve y equals to x squared and y squared equals to 8x. The intersection will be, okay, so you have to solve the equation x squared y equals to x squared, so x squared equals to square root of 8x, and the solution would be x equals to 0 and 2, so integral from 0 until 2, and the integrand is this one, so pi 8x minus x to the power 4 dx. Of course, if you want to solve this, just look for antiderivative of 8x, antiderivative of x to the power 4. That will be 4x squared minus x to the power 5 over 5. And x is from 0 until 2. Okay. If you calculate this, then you have goes to pi 4x squared. Okay, I will just copy first. X to the power 5 over 5, 0 and 2, pi for 2 squared minus 2 to the power 5 over 5 minus 0. And if you simplify this calculation, realize that 2 to the power 5 is 32 over 5. And this one is 16. Then you have 80 minus 32, which will be 48. So 48 pi over 5. Okay. Okay. Any question or comment up to this point? Any question or comment? Okay, so of course, if you take a look at this example, the method of washer, actually the method of this is a special case of a method of washer, but the second function or the second curve is actually y equals to 0 or the x-axis. Okay. So in general, if you the formula, if you consider, okay, let us say that you have the curve y equals to f of x, okay, and then here you have y equals to g of x. Then if you want to revolve this about the uh, x-axis, then you'll have an object whose volume is, okay, so first let us write the delta v. Delta v is approximately pi f of x square minus g of x square delta x. Of course, v will be the integral from a until b, okay, pi multiplied pi vx fx square minus g of x square dx. Okay. Of course, if you take if g of x is 0, then you will go back to the method of this. Okay. Okay. Any question or comment? Okay. If there is no question, then I'll continue. Okay. So method of this also works on an example where okay, where the and where the axis of the rotation is not just the x-axis or the y-axis only. Okay. For example, you may take a look at any vertical or horizontal line as given in the following example. Okay, so the next example, let us work on the case where the rotation, the axis of the rotation is not the x-axis or nor the y-axis. In this case, okay, so this is the example. The semicircular region, see, bounded by, let's say, the curve x equals to square root of 4 minus y square, let's say, and the y-axis is revolved about the line, let's say x equals to -1. Okay. Okay. So now, okay, write the volume of the solid as a definite integral. Although, okay, so in this case, we do not need to calculate the integral, just write the volume of the solids obtained by revolving semicircular region bounded by the curve x equals to 4 minus y square, square root of 4 minus y square, and the y-axis about the line x equals to -1. Okay, so let us now first sketch the curve and the region. Okay, where is the... Okay, this one. Can you see the curve, the sketch? Can you see it?
Yes, sir.
Okay, x equals to... What is the formula? I forget. X equals to
4 minus y square, sir.
4 minus y square squared. Okay, so this is just a semicircular region. Okay, so the region is bounded by this curve and also the line and also the y-axis. So yeah, this one, the y-axis. So the region is this one, right? Okay, but now it will be evolve about the line x equals to -1. Of course, if it's revolve about the y-axis, then you will have a sphere of radius 2, and obviously the volume will be 4/3 pi 2 to the power 3. That will be the volume. But now, okay, probably I will first zoom this. Okay, I will do this. I will zoom this, so I will have okay, I will have the line x equals to -1. X equals to -1. Okay, so this is the rotation axis, the axis of the rotation axis. Okay, so I will resketch the region. Okay, the region will be this one. Okay, and then we revolve this about the line x equals to -1. Okay, okay, the line x equals to -1. Of course, you'll have a circular cylinder, okay, inside there, but it's also this one. Okay, okay, probably along this one, okay, as well. Okay, so this is the... Okay, so in general, you will have its cross section is a generalized cylinder, and the thickness here is delta y. Okay, the thickness is delta y, and if we want to approximate its volume, okay, for example, the volume of this one, okay, so it's obviously delta, its approximation is delta y, it's approximately delta y, sorry, delta v, it's approximately delta y multiplied by the area of this one. Okay. Of course, the area will be, okay, so if you see the cross section, okay, then okay, what is the radius of the smaller circle? Will be 1 only, because it's just the distance from the line x equals to -1 to the line here x equals to 0, or y-axis. Okay, is inside here. And then what is the larger radius? The larger radius will be the distance from the rotation axis to the outer part of the region. Okay, so what is the distance here? Hello, what is the distance? Matthew, what is the distance, Matthew? Matthew? Zakwan?
The distance from the top to the bottom, would it be 4?
This one, the distance.
Oh, the distance would be 1 plus how much? 1 plus 2, 3. Would it be 3?
1 plus?
1 plus 2, like the radius of the
Okay.
smaller half
Yeah,
circle.
of course. In that case, so, but in general, you may also take what is the distance here.
Oh, then the distance would be 1 plus square root of 4 minus y squared.
Okay, good. So in general, the distance will be, okay, I will here 1 plus square root of 4 minus y squared. Okay. Square root of 4 minus y squared is just the distance from this curve to the y-axis, but you have the distance from the curve to the line x equals to -1 is 1 plus square root of 4 minus y squared. Okay. Yeah, it's better. So in this case, it's better to sketch the region and also the solids as well to approximate the volume of the thin pieces. Okay, right. Of course, if the rotation axis is let's say x equals to -3, then of course the distance becomes 3 plus square root of 4 minus y squared. Okay. Yeah, I think that the general approach can be used for let's say if the rotation axis is, of course, with a different region, if the rotation axis is in general x equals to a constant or y equals to a constant, just calculate the distance between the inner curve. Okay, in this case, the inner curve is just the line x equals to 0 to the rotation axis, as well as the distance from the outer curve to the rotation axis. Okay, so in this case, okay, here the radius is 1 plus square root of 4 minus y squared. So that's why the area here, just the area of the bigger or the larger circle minus the area of the smaller circle. And in this case, we will have pi, where is the color? Pi, the larger one is 1 plus square root of 4 minus y square minus pi 1 square. Yeah, of course, you have multiplied by delta y. Okay, any question up to this point? Aiska? Aiska? Ashifa?
Yes, sir.
Do you understand?
Yes.
Okay, how to construct the approximate value of the volume?
What, sir? I'm sorry.
Yeah, do you understand how to approximate delta V?
I still processing in my head, but I
Okay.
try to understand.
Okay. Okay, do you know how to obtain the larger radius?
I'm still trying to understand, sir.
Okay, so which one is the difficult one? Or do you know how to obtain the smaller radius?
I'm not quite sure.
Okay, the smaller radius is 1, right? Just the distance from the y-axis to the line x equals to, sorry, just the distance from the y-axis to the line x equals to -1, right?
Okay.
Okay, and then the distance from the outer curve, namely y equals to x equals to square root of 4 minus y squared, is the distance from here is 1. The distance from here to here is square root of 4 minus y squared. Okay, so that's why I put 1 plus square root of 4 minus y squared. All right.
Okay.
Okay. Any other question or comment?
Sir,
Yes.
No, sir.
where do you get for the 1 plus square root of 4 minus y squared?
Okay. How do I get this one?
Yeah, how do you get the plus
Okay.
4 minus y
Okay,
squared?
I will clear the drawing. Okay. So now we want to revolve this region, but the rotation axis is this line, x equals to -1. Up to this point, do you understand?
Yeah.
Okay. So if I revolve this region, okay, then the idea is that, okay, I will obtain this one, right? Okay, so this is the slice of the solids will be a thin cylinder, okay, right? The thin cylinder, okay, and the approximate value of the volume of the thin cylinder, just the thickness delta y multiplied by the area of the base, right? Do you understand up to this point?
Yes.
Okay, now what is the area of the base? The area of the base is just large, just looks like a ring like this, and you have the larger circle, okay, and then you have the smaller circle. And then how do you know the radius of the smaller circle? What is the radius of the smaller circle?
1.
1. Okay. So this is just the distance from the rotation axis to this one, right? To this part, to this line segment. Of course, we have to find the radius of the larger circle, right? So of course, if I draw once again, okay. So if the height of this point is y, right? Let's say y. Okay, what is the distance from this point to the red curve? That's will be x equals to 4 minus y squared. So the length of this line segment is square root of 4 minus y squared, right? But I have to measure the distance from this curve to the rotation axis. So that's why I did by 1.
Okay.
1 plus square root of 4 minus y squared. Okay. Any question?
No, sir. Okay.
Okay,
Thank you.
is it clear?
Yes.
Any other question? Other question? Okay, so let us continue. Okay, so I'll just write the delta V. So delta V is pi 1 plus square root of 4 minus y square minus pi 1 square. All of this multiplied by delta y. And if you simplify this become pi multiplied by 1 plus 2 square root of 4 minus y square plus 4 minus y square minus 1. Okay, delta y. Then you have pi 1 minus 1 is 0. So you have 4 minus y square plus 2 square root of 4 minus y square delta y. And if you calculate v, just simply take the summation and then take the limit, then you'll have v equals to, okay, so you have to know what is the range of y there. What is the range of y? In the picture, what is the range of y? Y is from -2 until 2. Then this is the integrand. So 4 minus y square plus 2 square root of 4 minus y square delta y. Okay. And okay, of course, yeah, the question is just stop like something is up to this point. But of course, you may calculate the integral as well. The integral of 4 minus y square, just find its antiderivative. And the third integral will be integral 2 times integral minus 2 until 2 square root of 4 minus y square. Just the interpretation is just the area of the semicircle of a radius 2. Of course, it will be pi 2 square divided by 2. So that's 2 pi. Okay, so if you continue, v will be equals to integral from -2 until 2 4 minus y square dy. Okay, and separately you have 2 integral from -2 until 2 square root of 4 minus y square dy. And then okay, so let us calculate the first integral. Integral from -2 until 2 4 minus y square dy is just 4y, or you may use the symmetry even. It's a even function. So from 0 until 2 4 minus y square dy will be 2 multiplied by 4y minus y cubed over 3. Put 0 and 2 there. Have 2 multiplied by 4 times 2 minus 8 over 3. So that will be 8 24, so 32 over 3. And then the second integral will be -2 until 2 square root of 4 minus y square dy. It's just the area of the semicircle of radius 2. So that will be pi 2 square over 2. And this becomes 2 pi, right? And then if you go back to the volume, the summation of the volume is 32 over 3 plus the 2 multiplied by 2 pi. So you have 32 over 3 plus 4 pi. That will be the result. Okay, any question or comment up to this point? Questions so far?
No, sir.
Okay. Okay, so next one. Okay, so if you okay, so the let us summarize the important point for the method of solid of revolution, and then the method of this and washer is that you have to know what is the region first, the sketch of the region. After that, figure out how do we calculate or approximate delta V. Okay? So once you get the approximation of delta V, then take the summation, and then taking the limit, then you have the volume as the integral. To calculate delta V, to approximate delta V, the basic idea is that to multiply it by the thickness of the cylinder multiplied by the area of the base. The area of the base for method of this is just a circle. Yeah, so just calculate the area of the circle, find the radius. The radius will be the distance from the region to the rotation axis. On the other hand, for the method of washers, okay, so the base is not just a circle, but it's a ring, in the sense of there are two circles of the different radius, and then the region is just uh, the area inside the larger circle, but it's outside the smaller circle. Of course, you have to know what is the radius of the smaller circle, and then what is the radius of the larger circle. Okay, okay. I think that's all for the method of this and washer. The next method is that it's not just the solid of revolution. Sometimes the solids, the information of solids is given in terms of the shape of the cross section. Okay? So in this case, the type will be solids with the noun cross sections. Okay? Other solids with noun cross section. Okay. Yeah. So usually the shape of the cross section here is given, and then we have to construct the or we have to approximate the volume of the slice of the piece in terms of the shape of the cross section and also the thickness. Okay? Okay, so in this case, so let us consider the following example. So the example will be light the base of a solid. For the first quadrant, plane region bounded by y equals to, let's say, 1 minus x squared over 4, the x-axis, and the y-axis. Okay. Suppose that cross sections perpendicular to the x-axis r squared. So the question is find the volume of the solid. So this is the equation. So I will repeat. Let the base of the solid of a solid for the first quadrant only, and the region will be a plane region bounded by y equals to minus x squared over 4, the x-axis and the y-axis. And suppose that the cross-section perpendicular to the x-axis are squares. The question is find the volume of the solid. Okay, same as before. The first important step will be to sketch the curve here and the region. Okay, so let us go back to this one. Okay, can you see the? Okay, good. So you have what is the formula? Y equals to 1 minus x squared over 4. Okay, right? Is it correct? Okay, but we only consider the first quadrant only. Okay, so we focus on this region only. Okay, only focus on this region, right? Okay, and then the another information is that the shape of the cross section are squares. Okay, the shape of the cross section perpendicular to the x-axis. So we perpendicular to this x-axis, so this direction, right? Okay, and the shape is a square. Okay, of course, the volume of the slice will be okay. So first, I should draw this region in this. Okay, so we consider this one. So the thickness should be delta x. Okay, and then since the shape is a square, okay, so let us draw once again this region, this direction. So here, suppose that this is the x direction there, this is y, and then the curve is this one. So we have this is the region, okay, and then the shape of the cross section is a square. So if you draw, let us draw something like this. Okay, then okay, probably this blue one, this one. So okay, so the okay, so if I draw, this is the thin piece here. So the corresponding cross section will be in this one, and the shape is a square. Okay, so the approximate value of the volume of this piece will be, okay, this piece will be the volume of the box. The volume of the box of the thickness is thickness is delta x multiplied by the area of the base. Okay, so delta V is approximately delta x, okay, the thickness multiplied by the area of x. Of course, okay, the area of the radius of the area of the square here should be the square of its side line. Okay, its side line, so if x is here, side line will be 1 minus x squared over 4. Okay, 1 minus x squared over 4. Okay, so in that case, you will have 1 minus x squared over 4 squared multiplied by delta x. Okay, is it clear up to this point? Is it clear? Rumi Robani?
Yes, sir.
Is it clear?
Somewhat, yes.
Okay, do you know how why I calculate 1 minus x squared over 4 squared, Rumi?
Is this the area of the semicircle?
The area of
The semicircle.
which one is a semicircle?
Oh, sorry, the quarter of the circle.
The area of square.
Oh,
And
this is the area.
this is a square.
Hmm.
Square, and its side line is 1 minus x squared over 4. Okay.
Okay.
Okay. Okay. So in this case, if you take the summation to this one, so V is approximately the summation of 1 minus x squared over 4 delta x. And if you take the limit as delta x tends to 0, you have V equals to the integral from what is the range of x? X will be, okay, so 1 minus x squared over 4 equals to 0. X would be equals to 2, right? 0 until 2. 1 minus x squared over 4 squared, yeah, forget this squared, dx, right? Okay, if you continue the calculation, the whiteboard. Okay, so the first step will be to approximate, of course, to sketch it, and then approximate the volume of the solid. The volume of the solid is 1 minus x squared over 4 squared delta x. Okay, you may calculate it here or up to the volume. Volume is approximation of summation of delta V, 1 minus x squared over 4 squared delta x. Taking the limit, you have the integral from 0 until 2, 1 minus x squared over 4 squared dx. Integral from 0 until 2, 1 minus x squared over 2 plus x to the power 4 over 16. Okay, and you dx. You have this one is x minus x cubed over 6 plus x to the power 5 over 80, then put 0 and 2 there. Okay, you may calculate this to obtain the volume. Okay, any question or comment? Okay, so let us consider one more example about the cross section here. Okay, second example. Suppose that now the base of solid is the region between, let's say, the curve y equals to sine x, okay, and the x-axis, and then, okay, and then let us suppose that each cross-section perpendicular to the x-axis is an equilateral triangle. Okay, that's the on this base. The question once again is to find the volume of the solid. So the first step will be to sketch the region, okay, but it's not that difficult because this is a familiar curve, y equals to sine x. Okay, that's from 0 until pi. Okay, so this is y equals to sine x. Here 0 until 1. Okay, so the idea is that we have the cross-section perpendicular to the x-axis. Let's say this one is x, and then the thickness is delta x. Okay, and then okay, so let us draw the base of the solid like this, and then okay, so this is the cross-section, okay, and then the shape will be if it's known that the shape is a equilateral triangle, okay. So in this case, okay, its a base is sine x, okay. However, we have to take a look at the area of this one. Yeah. So if I draw the triangle, thing like this, since it's a equilateral triangle, then you have this one is sine x, this one is sine x, this one is sine x as well. Then calculate the area. The area is just obtained by okay, calculate by this one. Yeah. Okay, of course, by Pythagorean formula you have, okay, that one is okay, so the height will be square root of sine x squared minus sine x over 2 squared. So the result will be the height of, or the altitude of the triangle will be h equals to okay, sine x squared minus sine x squared over 4 is just square root of 3 sine x squared over 4. That would be square root of 3 over 2 sine x. And the formula for the area of the triangle, the area of the triangle is half multiplied by the base of the triangle is sine x multiplied by its height, square root of 3 over 2 sine x. So that will be square root of 3 over 4 sine x squared. So in this case, the volume delta v, the volume of the cross section, is just the thickness of the cross section, namely delta x, then multiplied by the area of the the cross section. So we have the square root of 3/4 sine square x delta x. Of course, take the summation and then the limit. Then the integral is written as integral from 0 until pi square root of 3/4 sine x squared dx. Okay, of course, you have to calculate the integral. All right. Any question or comment so far?
Sir,
Yes.
I have
Yes.
mau siapa dulu, Zaf?
Okay. There are two questions.
It'll be a quick one. Sorry.
Yes,
So
that one.
why did we get the height to be 3/4 sine square x instead of just sine x?
The height of the triangle. This one,
Yeah.
square root of 3/2 sine x, yes. By Pythagorean formula.
Oh, but like
Sine x, this
so
one is
the
sine x over
shape.
2. Yes.
Also, we're taking the sine x to be the length of the equilateral triangle instead of being the height of the triangle.
Yeah. So because the shape of the solid here, because here the height here is the height of the base, but the solids here. Okay, I will draw it once again. Okay, so you have. Okay, I will draw it by the perspective here. So here is sine x, right?
Mhm.
Okay, and then the cross section, the shape of the cross section is this one, equilateral triangle. Then we want to know the area of this triangle. So that's why the base of the triangle is sine x, but we have to look for its height. Okay.
Oh, okay. So the height isn't sine x, but
The
one
height
of the
is-
side, like the sides are sine x.
Yes. Yeah. Actually, 3 sides are sine x because
Okay.
Because the because it's an equilateral triangle. It's given
Okay.
information.
Thank you, sir.
Okay. The second question, please.
It's answered already, sir.
Okay, it's the same. Okay. Okay, so that's the method of cross section. But now we want to okay. We want to continue the method of shells. The idea of the method of shells is as follows. So in this case, okay, similarly, sometimes you cannot just obtain the radius of the base in some particular case. However, the problem is that usually related to the inverse function. Sometimes it's not so easy to find the formula of the inverse of some function. So we have to look for how to see or how to approximate the piece of the volume by using another method. And then we call this method of shells. Okay, so volume of solids. But now volume of solids of revolution. But now we consider the method of shells. Okay. Okay, the method of shells. The idea is that we know that if you consider, okay, if you want to consider once again a cylinder, okay, something like this, okay, then you want to calculate the volume. Of course, is the area of the base multiplied by its height. Okay, volume of the area of base multiplied by the height of the cylinder. So in this case, if let us assume that the radius of the smaller circle is R1, and then the radius of the larger circle is R2, then of course you can calculate it by pi R2 square minus pi R1 square. Then all of this multiplied by the height, namely h. Okay, and you can take the factor of this to become pi R2 plus R1, R2 minus R1 multiplied by h. And then you can regroup this. I will put 2 pi there. Yeah, and then the reason will be clear later on. Yeah, I will continue h multiplied by R2 minus R1. Of course, I put R2 minus R1 there because it denotes the thickness of the slice here. Then the role will be delta x later on. Okay, and then I will put R1 plus R2 over 2 is actually the average of R1 and R2. Okay, if R2 if R1 and R2 are so close, then yeah, of course it's in between, then the value is similar to R1 and similar to R2. Okay, now okay, so okay, in this case we can write the formula of the volume will be 2 pi multiply the average of the radius and then multiply by the height. Okay, h is height, and then multiply the last term will be the thickness. Okay, okay, of course it's intuitive because we can abbreviate this to become 2 pi r h multiplied by delta r. Okay, and it's intuitive because if you consider the previous volume there, the previous general cylinder with the hole here, then if you cut the cylinder, okay, then you will have let's say the following one. Then you will have the really thin box here. Okay, and the dimension of the box will be, its length will be the perimeter of the circle, namely 2 pi r. Okay, and then the width is just the height of the cylinder. Okay, and the thickness is just the delta r. Okay, thickness is delta r. So that's why you have 2 pi r multiplied by h multiplied by delta r. Okay, okay, so we'll use this idea to find the volume of solids of revolution, and we call this by the method of shells. Okay, so that's the idea. All right, so let us continue. Okay, so the method of shells in this case, let us consider how we construct this. The idea is that if you draw the region, okay, let us consider that this is y equals to f of x, and then the region, let's say, is as follows. Then you take the partition here, slices, and then suppose that this is the particular case of the slice. Let's say this one is delta x. Okay. And this one is x. Let's say from A until B. Okay, so the idea is that if you have the thickness is delta x, the average radius will be x here. And the height here will be f of x. So in this case, the volume is approximate. Remember that the volume of piece of solid is approximated by the product of the average radius multiplied by 2 pi, and then multiply once again by f of x, the height, and then the thickness. So you have 2 pi x f of x delta x. And in this case, okay, the volume will be, after taking the summation and then taking the limit, you have v equals to 2 pi integral from a until b x f of x dx. Yeah, x f of x dx. Okay, so that's the general formula for this one. Okay. Okay, so let us see just one example for this method. Okay, one example. Example is that let us consider the region bounded by, let's say, y equals to square 1 over square root of x, the x-axis, and then x equals to 1 and x equals to 3, and then this region is revolved about the y-axis. Question is to find the volume of the resulting solid. Okay, find the volume of the resulting solid. Okay, so in this case, first, just like before, we have to sketch it, or okay. Okay, let us sketch the region. Okay, y equals to 1 over square root of x from x is from 1 until 3. It's from 1 until 3. Let's say here. And this is the curve. Okay. Okay, so let us consider this region, and then the same as before, just take the slice. Its thickness is delta x. Okay, and then if this is the distance is x, of course the height will be 1 over square root of x. Okay, so if you want to approximate the volume delta v, just 2 pi multiplied by the average radius is x, then multiplied by the height is 1 over square root of x, and multiplied by the thickness delta x. If you simplify this, then you will have 2 pi square root of x delta x. Of course, take the summation, you have the following approximation, and then if you take the integral, the limit as delta x tends to 0, you have the volume will be the integral from 1 until 3 2 pi square root of x dx. Okay. So in this case, you will have v, just the 2 pi is just a constant, and you have to look for the antiderivative of square root of x. Antiderivative of square root of x is x to the power 3 over 2, and forget multiply it by 2 over 3, and put x equals to 1 and 3 there. So you have 2 pi 2 over 3, 3 to the power 3 over 2 minus 2 over 3. Of course, you can simplify the reason. All right. Okay, so that's all for today. Any question or comment so far?
Sir, so the radius is x.
Yes, the radius is x in this case. The radius is x. The height is f of x, and in this case is 1 over the square root of x. And the thickness is delta x.
Oh,
That's why, yeah, you have this one. Observe that we cannot, we cannot just use the method of this or the method of washer or even this cross section, because here if you revolve this to the y-axis, then actually you should have the radius of this curve. Yeah, of course this curve cannot be written. Okay, so if this is x and y axis, of course this just cannot be written as the formula for one formula of a function of y. So x cannot be written just by one formula of y only, because actually this condensed into two parts. The first part is okay, so y equals to 1 over square root of x, so this is x equals to 1 over y squared. On the other hand, you will also have this part equals okay, so here this part equals x equals to 3 here. So if you want to consider the method of this, okay, you can do it. However, the method will be the result of this, the method of this or the washer here, you will have two integrals. One integral for revolving this region, another integral for revolving this region. Okay? So you'll see that the method of shells in some case is can simplify our calculation by the method of this or washer. Okay? Good. Method of shells in this case is a simplification. Okay, just calculate one integral only. Okay. All right. So in general, you have to decide which one is the suitable method, either this or washer. They are similar. Yes.
A question, if that's okay.
Yes.
I still don't understand how you get 2 pi x. Like I don't really get it.
2 pi x is okay. So I will repeat here. Okay. In this case, do you understand how to calculate the volume of the solids here? Okay, just this derivation. Okay, so in this case, you can simplify it as 2 pi average of radius. So x is the average of radius. I mean, the radius here is the distance between the rotation axis to the slices. Okay? So the average radius is x. Okay. Is it clear now? Is it clear now?
Yes, sir. Yes.
Okay. Okay, so in this particular case, you will see that, okay, the rotation axis is this one, the y-axis, and then the average radius is the distance from the rotation axis to the particular piece here. Okay, that's why I put 2 pi x multiplied by 1 over square root of x delta x. Okay, I think that's all for today. We'll have a quiz, don't forget, at 7 p.m. until 8. The same as before, we have 5 multiple choice question and 1 essay. The essay probably will be the area and the volume. Okay, maybe the area just standard, the area between the curves, and the volume maybe the method of washer or this method of shells probably is not included into the quiz, and 5 other multiple choice and short answer question will be the problem in chapter 4 or and in at the end of chapter 3. Okay, about the antiderivative. Okay, so I guess I will stop here. We'll close the recording.